speaker on this, Dr. Johannes Feidler. He is head of research on Doppelmayr Urban Solutions. Over to you, doctor, and I'm sure you will also help us understand a new mobility solutions in the offing.
Thank you. Thank you for coming to this session, which seems to have quite a focus on ropeways, which is by coincidence. I thank Dr. Kumar for giving this beautiful introduction into ropeway systems, and I also thank him for telling me the right word, which is Udan Katola. Is that right? Yeah? Okay. I will try to remember that. So we are the providers of ropeway technology worldwide. We are the biggest manufacturer of ropeway technology. We are based in Austria. Our company is based in Austria in a traditional tourist region, and that's where we developed this technology, and we keep developing it further all the time as the requests come in. In the meantime, we have production plants in many parts of the world, and since this year we also have a hub here in India. We are an Indian company. We are on the market developing projects in India. As for the size of our company, for Austria it's big. It might not be big for compared to some Indian companies, but in the world of ropeways, we are the biggest provider. We are a group of companies which have an overall turnover of some 800 million euros with 2,500 employees worldwide. And so far we have realized some 14,600 installations worldwide, and as we speak we are finishing more installations. I would like to focus on the urban application of ropeways. We have an experience with a new generation of urban cable systems worldwide. Here are some of the most important places where they have been realized. I'd also like to say that this is not a completely new phenomenon. We had in the early 20th century in many cities around the world, we already had a great variety of cable systems, funiculars, aerial cables, lifts, and they have served very, very well within the context of that time. Unfortunately, the technology was pulled out of the cities with the ascent of car mobility, but now it's coming back along with the other means of public transport. So we've been able to build very interesting projects in the past 10-15 years, such as this one in Portland in the US, linking the city center with a university campus, a couple of ropeways in Algeria where it fits very well into that specific structure of Algerian cities, Caracas, Venezuela, where it is highly effective in serving the informal parts of the city, which are located on the hills. And these ropeways give access to the dwellers of these areas. They give them access to the metro, to the other means of transport. We have finished one very spectacular installation in 2012 for the Olympic Games in London, crossing the River Thames, connecting two development areas which are now rapidly filling up. We have already seen the example from Singapore, which is certainly spectacular also for its integration into buildings. And the largest ropeway network is now in the making in La Paz in Bolivia. I will give you some details on that later on. But also in European cities, the request for this new generation of cable transport is emerging, and we are building and we're developing projects also with relation to historical cities. So this is to say that ropeways, cable installations, they go very well along with heritage sites because it has a low footprint, is little invasive, and it can be removed whenever it is no longer needed. It doesn't destroy the historical structure, but it gives a way to see it more effectively, to experience these places more effectively. By the way, ropeway is not always hanging on the rope. Ropeway technology is also funiculars, is people movers, which are vehicles that travel on a track, but they're towed, they're pulled by ropes. So coming to the specific subject of this session now, which is on electromobility, I collected some of the relevant aspects. Of course, I think this is clear in this context that when we talk about sustainable transport, we talk about public transport, collective transport, which goes along with a system of walking and cycling. So if we try to move transport towards higher degrees of sustainability and to a lesser footprint, we should not only think about the electric car, we should think about all the other electric modes, which include, of course, cable transport. We've heard cable cars are driven by electric energy, and they're driven in a very efficient way. However, whenever we talk about electricity, we need to think of where this electricity comes from. We have a great variety of renewable sources, but unfortunately, today, around 3/4 of all electric energy is still being produced from fossil sources. So as much as we move towards electric mobility, we have to move towards sustainable electricity production. I think this is something that is clear to everybody, but in day-to-day discussions is often being eclipsed. Cable systems are driven by electric energy, and they are driven in a very effective mode because the motor is not in the vehicle. The motor doesn't have to be carried around, but the motor is stationary in one of the stations along the line. It is placed where it can be best monitored and serviced, and it has a high degree of efficiency. So usually with a ropeway installation, you have at least two stations. You can have intermediate stations, and the motor can be placed at any station along the line. And each loop, if you talk about a rotating system, a revolving system, needs one motor. So motors are placed in the station, not in the vehicles. So often the question arises, what is the comparison in terms of energy consumption between the different modes of transport? We have evaluated the operation of our ropeway installations. Some of these installations are actually operated by Doppelmayr because we offer full packages, maintenance packages, service packages, but also operation packages. So the owner of the ropeway has nothing to do about the, let's say, the technical operation. So from that, we know exactly how much electricity we need to transport people, and the measurement for transport for energy consumption is kilowatt hours per passenger and trip. We have the comparison in cities like Vienna, what the other systems consume in terms of power, like trams, metro, buses. So in this comparison, roadway is significantly lower in consumption than, for example, a tram, and much lower than a metro. Always calculated per capita, yeah? Per capita, per trip performed. So there's a very good argument for applying roadways for the sake of energy efficiency. But of course, nobody will buy a roadway just because it is energy efficient. The roadway has to be judged from its transport function. And in that respect, we've seen already quite a few aspects. The roadway is very attractive. So if you calculate these numbers with reference to the CO2 footprint, then of course the question is how is the energy being produced? And in taking as a relation the production mix in Germany, which is not very favorable, yeah, as they have a lot of coal, a lot of thermic power plants, then the CO2 footprint of cable is still much lower than that of the tram. But if you have a chance to produce this energy in a sustainable way, then of course everything becomes even more attractive. For example, you can run a cable installation with solar power. So in order to run such a 3S roadway of 1 kilometer, you need more or less a 1 megawatt power plant, solar power plant, and that will be sufficient for the energy. But of course, as every engineer, as every engineer can assess, you need a grid backup because you need a steady supply, and the sun is not as strong as it's necessary all the time. So when connected to a reliable grid, it is possible to run a roadway entirely on solar energy in quantitative terms. And for the case of grid failure, which also happens, there is always an auxiliary diesel power unit in the station, in the drive station. That is a compulsory equipment whenever we build a roadway, let's say in places where power supply is not reliable. Short glimpse on the functions of mobility, the mobility functions. You see from this diagram that the roadway can act as a feeder to other systems in many ways. It can bridge certain obstacles. It can relieve certain corridors. Well, that's something I think very relevant for India. Run parallel to other corridors and can fill gaps and many more functions. In quantitative terms, we heard per direction we can transport 5,000 people, and this means that we can replace a huge number of cars. We can even replace a huge number of buses. So what is the relevance of this cable technology for India? I don't give answers here, but you certainly, as you see these images, I think everybody reacts by seeing that cable can actually run over congested areas. It can ease congestion, and it can, of course, facilitate rapid connections where ground traffic is stuck. It can overcome obstacles in places with difficult topography. In fact, we're about to build one installation in Shimla, which is this image shows. It can run over informal areas or areas where the building structure doesn't allow the construction of roads in a conventional way. That's, for example, what's being done in South America. And of course, it can, and I think this is the most important strategic aspect, it can provide an offer, a transport offer that reduces car dependency, an offer which is accepted by the middle class. I think this is an important fact, that public transport needs to be attractive to the middle class. Only then a shift in transport modes will be possible. If it is considered only a means of transport for the poor, then whoever gets out of poverty will shift to driving. But that's not what the future should be. The future should be that the middle class, those who can afford a car, actually opt for public transport in their everyday life, because it's more convenient, it is more sustainable. So this is my message, and I'm open to questions anytime. I'm around. Thank you.